Hello, thank you for being here. My name is Dongwon Lee and I work in Digital Strategy Bureau at KOSHA. KOSHA means Korea Occupational Safety and Health Agency. What I'm going to talk about today is progress and future development of KOSHA Big Data Platform for Industrial Accident Prevention. The presentation order is as follows. This is an introduction to KOSHA. KOSHA was established in 1987 to ensure the health and safety of Korean workers. KOSHA is in charge of the public sector between the government and private sectors. We operate under the Occupational Safety and Health Act and KOSHA Act. Our features are as follows. I'll skip it, but because the time is limited, for more information, please visit our website. Let's move on to the next topic. This is the development background of the Big Data platform. We have a roadmap for reducing serious injuries and fatalities that was issued by Korea Ministry of Employment and Labor last year. The fatality rate must be reduced to 0.29 by 2026. More than 800 workers die in accidents every year. The fatality rate per 10,000 people has been stagnant at 0.4 to 0.5 for 8 years. While the fatality rate per 10,000 people decreases every year, the proportion of accidental deaths in small business with less than 50 employees continues to increase. The picture shows the accidental death rate at workplaces with less than 50 employees. You can observe a continuous increase. According to the Korean government, the cost of losses due to industrial accident is increasing. It increased by 32.8% over 5 years. The cost of loss per victim is close to $199,000, which is 6.4 times the average pre-tax annual salary of Koreans in 2022. To achieve our roadmap goals, we plan to use big data and AI to create a model capable of predicting high-risk workplaces. Additionally, we intend to establish a big data platform utilizing it as fundamental data for industrial accident prevention activities. Now let's get into the main content. Let me start by explaining the services provided by our big data platform. This is the main screen of the platform we provide to our employees. First of all, the prediction of high-risk workplaces. This feature involves calculating the risk rate for all workplaces monthly using an AI learning model. It provides Excel downloads and map services for easy access and utilization of results. When we select search conditions as shown in the screen, the corresponding company will appear. Although it is written in Korean, it contains information such as company name, address, number of employees, industry name, and prediction results, and so on. If you click on a workplace in search results, it will provide more detailed information about the workplace. Let me briefly explain about the risk rate. The risk rate ranges from 0 to 1, and the closer it is to 1, the more dangerous it is. The AI model classifies the workplace as dangerous if the risk rate is over 0.5. The radar chart classifies workplaces information into 5 categories: human, machine, material, and internal and external environments. It visually represents the risk for each factor. The serious accident investigation reports have been digitized and can be searched. Various search conditions can be applied, for example, occurrence type, original cause materials or objects, workplace name, administrative district, and so on. This chapter is the core of what we have developed. This is an explanation of high-risk workplace prediction model. In order to reduce accidental death among workers, it is necessary to efficiently select and inspect target workplaces. Only around 10% of workplaces undergo in-person guidance and inspections annually. Determining which workplaces to include and exclude is a crucial concern for occupational safety and health. Until recently, in order to select a workplace, the target was selected by processing data based on individual knowledge and experience. There was a need to break away and select a workplace using a scientific method. Therefore, we established an annual development plan to scientifically and efficiently select workplaces. Last year was the last of 5-year plan. I will explain the basic process of AI model development. First, we collect workplace data. Data includes administrative data such as human, machine, material, environmental, or employment insurance obtained by visiting the workplace in KOSHA. Next, we pre-process the data. Our data has many missing values. This is because only a small portion of all manufacturing workplaces can actually collect data. So we replace missing values with the multiple imputation method. And since there are more than 1,000 variables input into the model, variables with similar meaning are combined or derived variables are created to reduce the dimension. Then we do data analysis. Starting with basic descriptive statistics, unnecessary variables are removed using statistical techniques such as correlation analysis, VIF, lasso, ridge, and elastic net. The pre-processed data set is split into a training set and a test set to train the AI model. And the reason for resampling is that the purpose of our model is to predict disasters such as accidental death. The ratio of target value is significantly low. So we try to resolve the data imbalance through resampling. We created a model by applying various AI methods. Currently, major AI techniques were applied, such as machine learning, deep learning, and anomaly detection techniques. In addition, methods such as randomized search were also used to adjust the optimal hyperparameters. As a result of trying various algorithms, we adopted the model that had the most stable performance and could well predict industrial accidents. As we will explain in detail later, the performance of our model is around 73%. Then I will talk about the model development concept. I thought that the overall level of safety and health could be improved if relatively high-risk workplaces were selected from the entire list of workplaces and provided guidance and inspection. If poor workplaces are selected, provided with guidance and inspection, safety and health levels will improve after support. So which workplaces should we target? To do this, high-risk workplaces must be defined. Additionally, a way to calculate the risk rate must exist, and we need to set an appropriate cutoff line. First, the risk rate quantifies the relative risk between 0 and 1. And when the risk rate was over 0.5, a cutoff line was set as a high-risk workplace. This is the part we were most concerned about. How should we define a high-risk workplace? Let's think about this. Is it necessarily dangerous if it is a workplace where many accidents occur? Is it dangerous having lots of machines? Will an employer's high or low safety awareness lead to industrial accidents? And is the safety awareness of employers measurable? We would like to consider all kinds of data and transform them to both quantitative and qualitative factors. But we have insufficient data, and data should be measurable. We decide to consider both intensity and frequency when industrial accidents occur. Therefore, we select workplaces as a target where work losses were higher than the average when an industrial accidents occur. Additionally, it also includes workplaces supervised by the Ministry of Employment and Labor. This is because workplaces refer to the Ministry of Employment and Labor for supervision and administrative action when their safety and health management is found to be extremely poor or dangerous conditions during on-site inspection. Although industrial accidents have not occurred as of now, the possibility of them occurring is very high. Then I will explain with the example how to define high risk through work loss. At workplace A, if 10 people were injured for 10 days each, 10 times 10 results in 100 work losses. At workplace B, one person was injured for 50 days, so 50 times 1 result in 50 work losses. At workplace C, one person died in an accident. Deaths were calculated at 7,500 days, resulting in a labor loss of 7,500 work losses. If the average work loss for workplaces of the same industry and size is 60 days, workplaces A and C are higher than the average. In this way, we define high-risk workplaces by considering intensity and frequency. Based on AI modeling procedure explained previously and definition of high-risk workplaces, a prediction model was developed as shown in the figure. The AI model was developed for 3 industries: manufacturing, construction, and service. A total of 3,300 modeling runs were performed. As for the algorithm, XGBoost was finally selected among the machine learning methods. Finally, 417 variables were selected for the manufacturing industry, 413 variables for the construction industry, and 471 variables for the service industry. Looking at the data characteristics by industry, the manufacturing industry maintains a relatively fixed workplace compared to other industries. So it was possible to accumulate data periodically. The construction industry opens and closes frequently and has fixed periods, so there were limitations to regular data collection. The service industry is a small business. It was not easy to obtain information. Now let's look at the model's performance. Manufacturing came in at 0.73. The interpretation of performance can be interpreted as that when KOSHA visit workplaces, 73 out of 100 workplaces have higher than the average work losses. It is 0.72 for construction and 0.67 for services. When verification was done with actual industrial accident statistics, more industrial accidents occur in workplaces selected by the AI model as high-risk workplaces. In the manufacturing industry, there are 80,000 high-risk workplaces out of 400,000 workplaces, but 113 of 155 accidental deaths occurred in high-risk workplaces. From the perspective of lost working days, when the workplace risk level was set to 0.1 units, the average number of lost working days increased as the risk rate values increased. In other words, it is judged that industrial accidents occur more frequently or more seriously at workplaces selected by the AI model. Lastly, the direction of development. This is Big Data Department's next 5-year plan. The core development direction is to handle unstructured data. So we want to create an environment where unstructured data can be collected, loaded, and analyzed. We plan to provide services to the public in the future by upgrading our high-risk workplace prediction model. We want to build a system that allows business owners or workers to easily identify risk factors in the workplace. If the big data platform becomes more advanced, we would like to provide data and API to the public. We also want to prepare for future technologies. Natural language processing models such as BERT and GPT are popular now. Although we are in the early stages, we are developing languages models focused on and specializing in the field of occupational safety and health. This AI is a model that learned industrial accident classification results. Currently, KOSHA employees read and classify industrial accidents, but this AI model automatically classifies industrial accidents. Current performance is around 80% in accuracy. The AI model can independently analyze the causes of industrial accidents. When we enter an industrial accident case, a report is created with an overview, industry, type of work, causes, and reduction measures. Lastly, we can request to create the industrial accident case. When we ask the AI model to create disaster cases during logging accidents, the following cases are generated. Thank you for your hard work listening to my English presentation. If you have any questions, please ask me by email. I will answer you by email later. Thank you.